Imagine a world where deals can't be broken, because the code won't let them. Welcome to smart contracts. What is a smart contract? A smart contract is code that runs on a blockchain. Think of it like a digital robot that follows instructions automatically. It executes when certain conditions are met, no human needed. Someone sets the rules, the code enforces them perfectly, every single time. No middleman, no negotiation, no delays, no excuses. The simplest way to understand it, it's like a vending machine. You insert $1, select your drink, and the machine automatically gives you a soda. The machine doesn't negotiate the price. It doesn't ask for your ID. It doesn't take sick days. Smart contracts work the same way. Insert the right input, get the guaranteed output, every time, without fail. But instead of candy bars, smart contracts can handle loans, insurance payouts, stock trades, or million-dollar real estate deals. Why do smart contracts matter? Smart contracts remove the need for trust between strangers. The code becomes the law, neutral, predictable, and unchangeable. Traditional contracts require lawyers, agents, escrow services, and lots of paperwork. All those people need to be paid, trusted, and coordinated. Smart contracts eliminate most of that overhead. Once a smart contract is deployed to the blockchain, it cannot be edited. The rules are set in stone. This means both sides know exactly what will happen under every possible scenario. Everything is transparent. Anyone can read the contract code and verify that it does exactly what it claims to do. No hidden clauses, no fine print surprises. The contract runs exactly as programmed, whether it's handling $10 or $10 million. It doesn't care about your credit score, your nationality, or your connections. It just follows the code. This creates a level playing field where the rules apply equally to everyone, enforced by mathematics rather than human judgment. Real-life example, buying an NFT. Let's see this in action. When you click Buy NFT on OpenSea, you're not just making a purchase, you're triggering a smart contract. Here's what happens in those few seconds. The smart contract checks your wallet to make sure you have enough cryptocurrency. It verifies that the NFT is actually owned by the seller and available for sale. If everything checks out, the contract simultaneously transfers your payment to the seller and transfers the NFT ownership to your wallet. This happens in one atomic transaction, meaning either everything succeeds together or everything fails together. You can't end up paying money without receiving the NFT or receiving the NFT without paying. No human could process this trade fast enough or reliably enough. The smart contract handles verification, payment, and transfer in seconds, with zero possibility of fraud from either side. And it works 24/7. You can buy NFTs at 3 a.m. on Christmas Day. The smart contract doesn't take holidays, doesn't sleep, and never needs coffee breaks. How smart contracts actually work. Smart contracts are written in programming languages designed for blockchain. On Ethereum, most use a language called Solidity. Other blockchains have their own languages. The code gets compiled and deployed to the blockchain, where it lives forever at a specific address. Think of it like uploading a program to a global computer that never shuts down. Most smart contracts have front-end applications, websites, or apps that make them easier to use. These are called DApps, or decentralized applications, but the smart contract itself lives on the blockchain, not on any company's servers. The front end could disappear, but the smart contract would keep running. Once deployed, anyone can interact with the contract by sending it transactions. You don't need permission from the developer or any central authority. Popular smart contract platforms include Ethereum, which pioneered the concept, Solana for high-speed applications, and newer chains like Avalanche and Polygon. Each blockchain has different capabilities, fees, and performance characteristics, but they all enable code to run in a decentralized, trustless environment. The key insight is that smart contracts turn blockchains from simple payment systems into programmable platforms that can automate complex business logic. Benefits of smart contracts. Speed is a major advantage. Traditional contracts often take days or weeks to execute as various parties review, approve, and process paperwork. Smart contracts execute in minutes or seconds. Cost efficiency comes from eliminating intermediaries. No lawyers billing by the hour, no escrow agents taking fees, no administrative overhead for routine transactions. The trustless nature means you can do business with complete strangers anywhere in the world. The code guarantees performance, so you don't need to research the other party's reputation or credit history. Global accessibility removes geographic barriers. A farmer in Kenya can get a crop insurance payout from a smart contract triggered by weather data without dealing with local insurance companies or currency exchanges. Programmability allows for complex logic that would be expensive or impossible to implement with traditional contracts. Multi-party agreements, conditional payments, and automated compliance become straightforward. Transparency ensures all parties can verify the contract logic before agreeing to it. No surprises, no hidden terms that only lawyers understand. Risks and limitations. Code bugs can lead to serious financial losses. Unlike traditional software, smart contract bugs can't be patched after deployment. Once the code is live, the bugs are permanent. The lack of human judgment can be problematic. Smart contracts can't handle edge cases or unusual situations that weren't anticipated by the programmer. They follow the code literally, even when common sense would suggest a different outcome. Permanence cuts both ways. Once deployed, smart contracts are public and unchangeable. This transparency is good for trust, but bad for trade secrets or evolving business requirements. Technical audits are essential but expensive. Many projects skip proper security reviews to save money and time, leading to vulnerable contracts that get exploited by hackers. The Oracle problem affects contracts that need real-world data. Smart contracts can't access information outside the blockchain without external data feeds, which reintroduces trust issues. Legal uncertainty remains in many jurisdictions. It's unclear how traditional legal systems will treat smart contract disputes or whether they'll be recognized as legally binding. Where smart contracts are used today, DeFi applications represent the largest use case. Protocols like Uniswap use smart contracts to enable automated trading without traditional exchanges. Compound enables lending and borrowing without banks. Aave provides flash loans that would be impossible in traditional finance. NFT marketplaces rely entirely on smart contracts for minting, buying, selling, and tracking royalty payments. Every NFT transaction involves multiple smart contracts working together. DAOs use smart contracts for governance and treasury management. Token holders can vote on proposals, and the smart contracts automatically execute approved decisions without human intervention. Gaming applications use smart contracts to manage in-game economies, item ownership, and player interactions. Items truly belong to players rather than game companies. Insurance protocols use smart contracts to automate claim payouts based on verifiable data. Flight delay insurance can pay out automatically when airport databases confirm delays. Supply chain tracking uses smart contracts to verify product authenticity and track ownership transfers from manufacturer to consumer. Future of smart contracts. User-friendly interfaces are evolving rapidly. Soon, interacting with smart contracts will feel as simple as using any other app, hiding the technical complexity from end users. Legal smart contracts may bridge traditional law and blockchain technology. Real estate transactions, employment contracts, and business agreements could be partially or fully automated. AI-assisted development could help write more secure and efficient smart contract code, reducing the risk of bugs and vulnerabilities. Integration with traditional systems is already beginning. Banks and corporations are experimenting with smart contracts for internal processes and customer services. Cross-chain interoperability will allow smart contracts on different blockchains to work together, creating more powerful and flexible applications. Regulatory frameworks are developing that could provide legal certainty and encourage broader adoption in traditional industries. The technology is moving toward making smart contracts as common and reliable as email or online banking. Smart contracts don't wait, don't forget, and don't lie. They execute exactly as programmed every single time without human error or bias. They're not just code. They're the foundation of a new kind of economy where agreements enforce themselves and trust is built into the system itself. From DeFi to NFTs to DAOs, smart contracts are already changing how we handle money, ownership, and organization. Like, subscribe, and join us next time as we unpack what is market cap in crypto, why it matters, and why beginners often ignore it.